Okay, I'm going to introduce section 6.3, was about square root functions, and I'll start, you might ask, why have I already drawn y equal x squared? And it goes back to this idea that inverse functions are undoers. So if you think about it, what would be the function that undoes x squared? So to undo a square, I would then take a square root, and I will have undone it. So I'm expecting the square root to be the inverse of x squared. So I'm going to start with this, but I'm going to notice that this is not a one-to-one function, and so it won't have an inverse function. So we have to do our trick where we restrict the domain, right? So what we're going to do is we're going to say, this is my function, but I'm going to restrict x has to be greater than or equal to 0. Because if I do that, then I have just this red part, right? And in fact, I could go ahead and erase the other part, right? That's all gone. So I only have the red. And now it's one-to-one. Now I'm going to have an inverse. Okay, so I have that done. And we can play our trick with swapping the x's and y's, so that other central theme of inverses. Let's grab a pen. Let's start labeling some points. On my parabola, of course, I had 0, 0, I had 1, 1, and I had 2, 4. So what happens is when I go to the square root, or what I'm expecting to be a square root function, so let's see, let's make sure we've labeled this one as f, okay, so I'm going to label this one as f inverse, and I'll have all the same points with x's and y's swapped. So I still have 0, 0, I still have 1, 1, nothing special there, but here's where things get interesting. 2, 4 swaps to become 4, 2. 1, 2, 3, 4, 2. So that becomes my 4, 2 point. And I can connect the dots. And it looks like this. And there's a couple of things we want to say about this graph. Number one, let's be clear. This one is always increasing. You know, don't let it ever change downhill, right? So it's always increasing. I can notice this graph has a domain where the x values are only greater than or equal to 0. I can notice that the range is such that the y values are also greater than or equal to 0. So I have this function, and let's be clear that this is indeed what we are going to label f inverse of x. This graph is the square root of x. And a lot of times we use y when we're doing graphing. So I have this idea, and I want to go back to one other point to be made. First, you know, we talked about if you're swapping the x's and the y's, that means you're swapping your domains and your ranges. So let's see that that did happen. This x greater than 0 turned into the y greater than 0. And this domain of x greater than 0 really is coming from the range of this function being y greater than or equal to 0. And you can see from the graph that's exactly what we had. The other thing I want to notice is this reflection across the x-axis. It's a little hard to see, we're on the two different graphs, but if I were to try and put them on the same graph, you know, you have the one doing this, and you have the other one doing this. And can you see, if you try the vertical, or sorry, not vertical, but just a reflection across this dotted line, which doesn't need to go this direction in the negative, but this is your line y equal x, and if I reflect across that line, the red becomes the green. Notice that they intersect, the red and the green intersect at where it also intersects with y equal x, okay? So that when you switch y equal x, of course, there's no change. We need to spend just a minute talking about domains because we know we cannot take square roots of negative, okay? We don't want those imaginary. So the square root of a negative is imaginary, and we don't want that for our functions or our graphs, okay? So if we're talking about real numbers and we want x's to be real and we want our y's to be real, then we have to say that that radicand cannot be negative. So we say it's greater than or equal to 0. What do I mean by radicand? Let's make sure you know that word. That is whatever is under the radical symbol. Okay, so let's do an example really quick. If I had a function, let me use y for a minute, is a square root of x plus 3. Then I would say that my radicand, let me find the radicand first. It's everything under the square root symbol. That x plus 3, following my rule now, has to be greater than or equal to 0. If I take that and I solve it for x, x must be greater than or equal to a negative 3. That's my domain. Okay? So I have this very important rule for domains. If there is a radicand in your function, you better make sure that that radicand is positive or 0, because I'll remind you, the square root of 0 is just 0. We can do that, okay? And that just leaves us to talk about transformations, okay? And just like any other parent function, we would have, in this case, started with parent function y is equal to square root of x. That's what we've been drawing. And then we can start with our transformations. And it's all the same that we've done before. This plus k is a shift, right? Horizontal, left or right. The k is your up and down shift. A is your vertical stretch, and then the negative side would be your vertical reflection. And I point this out because what I really want to talk about right now, because we should be able to do these standard reflections now, standard transformations of all kinds that we've already done. But the one I want to talk about is a new one, okay? Let's talk about horizontal reflections, because it gets interesting for square roots. And in these horizontal reflections, okay, what are we talking about? Let's go back to the most basic one. Y is equal to square root symbol, and inside the square root symbol is times negative 1, okay? So it's a negative x. Much like we had this negative, meaning a vertical reflection, this negative, because he's inside, means a horizontal reflection. So x's are going to become negative x's, right? In order to have the same y value, you could say this is a reflection horizontally, which is another way to say across the y-axis, you know. Change all your x's into negative x's and you've accomplished that reflection. So what does it look like? Let me make sure we're appreciating this. When I draw this graph, I still have 0, 0, because a negative sign doesn't affect it. But then I'm going to go to the left, like so. And the 1, 1 point is going this direction, so he's actually negative 1, 1 now. And same with the 4, 2 point, 1, 2, 3, 4. It was close. Negative 4, 2 point. Okay? So that's a horizontal reflection. Another interesting point to make is domains and ranges, of course. The domain would be x is less than or equal to 0, but the range in this case is unchanged, greater than or equal to 0. All right, just to sum it up then, we have a new parent function, y is equal to the square root of x, 0, 0, 1, 1, 4, 2, okay? only that one little piece, right? It's x has to be greater than or equal to 0 here. So we do not have an all real number domain, which is a bit unusual for us. And then you could do that horizontal reflection. Y is equal to the square root of negative x. It's going to start 0, 0, but go left. And this idea that when you're thinking about domains, your radicands cannot be negative. So use this rule.